The spindle assembly is one of the most critical components to consider when evaluating a machine tool's overall performance. A problem spindle can reduce accuracy, shorten tool life, and reduce production. Maintaining optimum spindle performance is critical. How do you know when it's time to overhaul a spindle? And what are some of the things you should consider before rebuilding one? This presentation will try and answer these and other spindle repair questions. A spindle is a means of transferring a highly accurate rotary motion from a drive unit, typically a motor, to a tool like a grinding wheel, chuck, or insert. Supporting the spindle shaft are ball bearings, which give the shaft rigidity, yet allow almost friction-free rotation. Theoretically, the more precise the shaft, housing, and bearing tolerances, the more precise the cut or grind will be. Bearings also help provide shaft rigidity depending upon the size and type of bearings used, the size and number of balls, preload factors, and other design and selection considerations. The enemy with any machining operation, and with spindle assemblies in particular, is vibration. Geometric accuracy in a finished part can only be achieved when all tolerance variables have been optimized and vibration has been reduced or eliminated. Barden super precision angular contact machine tool spindle bearings minimize vibration because they meet or exceed ABEC 9 tolerances, the toughest, most rigorous standards in the industry. What are some of the signs that a spindle may be due for an overhaul? Some of the indications include excessive noise or vibration, loss of tolerance, diminishing part quality, and elevated operating temperatures.
If you're not performing regular maintenance on your spindles at prescribed intervals, you need to pay close attention to these warning signs.
If you suspect you have a problem spindle, you must perform a vibration analysis to verify its condition. This can be done easily using a portable vibration analyzer. This unit is a combination accelerometer and spectrum analyzer, which provides readouts of spindle vibration at designated frequencies and speeds. Analysis of the spindle is more accurate when a magnetic rare earth mounting button, specifically designed for curved surfaces, is used. Temporarily glue the button onto the front cap of the spindle using an instant superbonder adhesive. This ensures accurate transmission of vibration data through the probe. Measurements should be taken at 5 points on the spindle to obtain a more accurate reading. Take 2 readings each on the front and rear cap assemblies to measure horizontal and vertical noise. Take a 5th measurement on the front cap to measure axial noise. Comparison of known data will reveal if the spindle needs repair. Higher spike indicates a high level of vibration. Running a spindle at faster speeds typically produces higher vibration levels. Once it has been determined that a spindle needs repair, it must be removed from the machine and brought into a clean work environment. The importance of cleanliness in all phases of spindle repair can't be overstressed. Foreign particles like dirt, dust, a human hair, even industrial smoke can damage a precision bearing and spindle assembly. Craft paper, stainless steel, splinter-free hardwoods, or dense, non-shredding rubber mats are ideal work surfaces. Rusted or painted metal areas are unacceptable. Once a clean work area has been designated, the next step is to assemble all the proper tools you will need. These include hook spanners, drifts, a variety of Allen and open-end wrenches, gauges and gauge blocks. You will also need an arbor press for fitting bearings onto the shaft. Be sure all tools are unplated, chip-free, rust-free, and are kept clean. The next step is to disassemble the spindle. Review engineering blueprints of the spindle to familiarize yourself with the design prior to disassembly. If prints are not available, you will need to make careful, detailed notes of the way bearings and spacers are mounted. One helpful technique is to arrange parts in the order in which they are removed from the spindle. Begin disassembly by removing the quill from the end cap. Next, remove the end cap by applying an equal number of rotations to loosen set screws. Loosen screws in alternating sequence around the circumference of the end cap. Then, carefully remove the spindle assembly from the housing. Be sure to store any parts removed from the spindle assembly in a clean tray. When all components have been disassembled, you will need to inspect all parts for any obvious signs of trouble. Clues as to why a spindle may be underperforming often can be found in the condition of the bearings. Here are 12 of the most common types of ball bearing failure modes and the signs of what to look for. Severe spalling in the raceways is a sign of excessive load which can cause premature fatigue. Blue-black or silver-gold discoloration of the rings indicates overheating. Tiny elliptical wear marks at regularly spaced intervals in an axial direction indicates false brinelling, a result of excessive external vibration when the bearing is not in motion. True brinelling, more pronounced indentations in the rings, occurs when loads exceed the elastic limits of the ring material. Spalling or fractures in the running surface show signs of normal fatigue failure. A band around the circumference of the balls indicates reverse loading. Angular contact bearings are designed to accept loads in one direction only. Irregular dents or material embedded in the raceway is a sign of contamination. Discolored balls, either blue-brown or silver-gold, is a sign of lubricant failure. Red or brown stains on rings indicate a corrosion problem. Misalignment is the cause if the inner ring has a wide ball path and the outer ring shows a non-parallel ball path. Scoring or discoloration of the outer ring is a sign that there is a loose fit problem between the housing and the outer ring. Heavy wear deep in the ball path at the bottom of raceways indicates a tight fit. It is important to thoroughly check all spindle components prior to reassembly. First, visually inspect surfaces for wear, signs of fatigue or other abnormalities. Next, wash all parts in a suitable compound to remove all traces of lubricant. It should be noted that Barden recommends replacing old bearings with new Barden Super Precision bearings. Once parts have been cleaned and all components visually inspected, they must be measured with a variety of instruments and gauge blocks to verify geometric tolerances. This procedure includes checking shaft runout and measuring the nose of the shaft and bearing seats. You should also check front and rear spacers and housing bores. Note that any out of roundness in the shaft or housing will transfer into the bearing raceway when line-to-line or press fits are used. A polar plot reveals the roundness characteristics of this particular shaft being measured. The qualities to look for during an inspection include flatness, squareness, parallelism, roundness, bore, and diameter. Other types of measurements may be necessary to optimize spindle performance. These include shaft balancing and testing of an assembled spindle on a run-in stand prior to reinstallation into the machine. If you do not have this type of test equipment, a spindle repair facility can provide this service for you. Typical problems revealed through measurement analysis can include improper geometry, incorrect spacers, and worn housing seats or shafts. Most of these problems can be easily corrected. Prior to spindle reassembly, you should observe a few precautions when handling super precision bearings. Don't open the protective pouch until you are ready to install bearings. If bearings are unwrapped, keep them covered at all times. Don't wash new bearings because they are already factory cleaned and lubricated. Don't wipe parts dry with a rag or spin bearings with compressed air. You will introduce contaminants or cause internal damage to the bearing. Should you want to add lubricant, never mix different lubricant families or add more lubricant than necessary. Never use a hammer or screwdriver to install bearings. And don't smoke, eat, or drink while handling or installing bearings. Proper reassembly techniques include replacing old bearings with new Barden Super Precision bearings. Cleaning and reinstalling old precision bearings is not recommended and may result in damage to your spindle assembly. When you are ready to install bearings, carefully open the plastic pouch and remove bearing. Then, install the inner ring on the shaft using an arbor press. Make sure that the high points of eccentricity marks on the inner ring and shaft are aligned 180 degrees apart. Inner race high points, bearing to bearing, should be in line. With the arbor press and drifts, gently press fit the bearing onto the shaft. Never apply press loads through the balls. Inner ring tooling should only be used on an inner ring press. Outer ring tooling only on an outer ring press. Next, install any spacers required. Install remaining bearings the same way. End caps are the next component to be assembled. Use a bench vise with soft jaws to hold the shaft when locking the front nut. Do not clamp the bearing surface. When bearing, spacer, end cap and shaft assembly is complete, it is time to install the assembly in the spindle housing. When attaching the spindle cap, be sure to turn screws in equal rotations in sequence. Install the rear unit preload springs and spacers next. Then, install the rear end caps. When assembly is complete, conduct a final spindle test on a run-in test stand to verify performance with a spectrum analyzer. Some grease-lubricated bearings may require a special run-in procedure. If you are not sure if this condition applies, ask your Barden representative. Finally, when all testing has been completed, the finished spindle assembly is ready to be installed in the machine. Attention to these guidelines will ensure optimum performance and long life for your machine tool spindle assembly.